So last time, we looked at developing the formula for the price elasticity of demand. Now, let's look at some of the benefits of using that particular formula. And the first one that we want to look at is, why is it in percentage terms? And first, let's think about why we use the price elasticity of demand. And one of the big reasons is that we're interested in that behavioral change, right? Which is, if the price is changing, how big is that quantity response, right? As the quantity of demand increases from a price decrease, the price elasticity of demand gives us some insight into how big that change is. So it's really a measure of the consumer's behavior. And one way to look at that is, if it's a behavioral change, then it really shouldn't matter how we measure the particular variables. So in the example that we started with, we looked at the number of cases of soda that were sold per week. And we could do the same thing here, but now imagine that we have two ways of measuring the quantity that's sold. We can either measure it in cases, or we could measure it in, say, volume, like gallons. And let's take a look how that would change the model if we didn't use percentages. So now what we have here is the demand curve that we were talking about before. So we look at that price drop from $14 to $11.50, and so that's a drop of $2.50. And then that causes an increase in the quantity from 80 to 100. So we can describe that as a price drop of $2.50 actually leads us to an increase of 20 cases. And what I want to do is imagine, what if we measured this in a different fashion? And one thing that we could look at is, this is in case terms. What would it look like in, say, gallon terms? So what we need is now to think about this 20, but now in terms of gallons. And what we need to do is kind of think about how many gallons in a case of soda. So we have 24 cans, and each one of those cans is 12 ounces. And so what we have here then is a total of 288 ounces in a case. But that doesn't help us, right? That's ounces. And how many ounces in a gallon? What we see is that's 128 ounces in 1 gallon. That then would lead us to having a total here of 288 is now 180 gallons. Now, in terms of the 100, that's 225 sort of gallons. So these are in cases, and this is in gallon terms. Well, would this change the way that we measure elasticity if we now used cases or gallons? You'll notice we're still talking about this point on the demand curve and this point, right? The change is exactly the same. So what we really want is the measure of elasticity to give us the same result. And so let's go ahead and take a look at what that would look like. So the elasticity of demand when we're using cases, what does that look like? Well, it's the absolute value of the change in quantity divided by the change in price. So here the change in quantity is 20, all divided by the change in price minus 2.5. And so what do we get here? This would actually be -8 or 8. Now, if we talk about the elasticity of demand, but in terms of gallons, what do we get? Well, we have the same change in price, but now you'll notice we go from 180 to 225. We have a gain of 45 gallons. And so this is actually 18. So you see, one of the big problems in not using percentages would be we get a very different result, whether we're talking cases or gallons. And yet, we're really using the same behavior, right? We're capturing that same change in the consumer's buying habits that results from a $2.50 price decrease. And so this is the big problem that we try to eliminate by using percentage terms.